to do something that the book actually talks a little bit about back in chapter 5. I choose to not talk about this in chapter 5 because when it's addressed in chapter 5 in the book, it must be done by check, which is how I was taught this, and I am a horrible guesser. So if there are like 20 ways that I could do something, I was taught these said, well, you just have to guess and check. And I would spend hours on my homework and get so frustrated. I just kept thinking, there's got to be a better way. Like, please, there's got to be a better way. I'm spending forever on this. I'm not good at guessing. Help me out. And they're like, no, you just have to guess and check. And so when I started teaching Algebra 2, I was like, I don't want to teach this because I remembered hating it. And guessing is not really a skill that can be taught. So several years back now, one year we had to have a part-time teacher hired to help teach Algebra 2 because there were like 5 or 6 sections of it. Something weird happened that year, and we needed tons of sections of Algebra 2. So we had to hire a part-time teacher. And she was like, I've got the coolest way to do this. You don't have to guess at all. And I was like, the angels are singing for me. Like, I can finally do this without having to do any guessing. So now I enjoy teaching this idea, but I can't teach it back in chapter 5, where it kind of belongs, because the method we're going to use is going to involve some factor by grouping, which is something that we learned yesterday. So we're going to start the lesson with doing 2, and then we're going to combine ideas to get this new thing. So the first review topic is the idea of how we factored quadratics back in chapter 5. When we factored quadratics back in chapter 5, our method was that we would look for numbers that multiplied to be C that added to be B, the middle term. Right, so we'd make a list of numbers that multiplied to be C and find the pair that in some way could add up to be B. So let's refresh that idea, make sure we're good with that idea. In this problem, I would want to find numbers that multiply to make negative 28. So 1, 28, 2, 14, 4, 7. I need to pick the set that in some way I can get a negative 12 out of. Positive 2 and negative 14, I can get a negative 12 out of, and when I multiply, I get a negative 28. So then we write our factors as x plus 2 and x minus 14. And if we would FOIL that back out, we should end up back where we started. Let's do one more example of this. So positive 16, I need numbers that multiply to positive 16. 1 and 16, 2 and 8, 4 and 4. How can I get a negative 10? Negative 2 and negative 8 would multiply to give positive 16 and add to give negative 10. So x minus 2 and x minus 8. All right? Questions on that? It's an old idea. Chapter 5 tested a couple tests ago. We're going to bring back that idea today, though. We are also going to talk about factor by grouping again, which we talked about. When we factor by grouping, we're going to have 4 terms. We begin by grouping first 2 terms and second 2 terms, factoring out what's in common in each group, and then what's left over inside those parentheses should match. So our final in those parentheses times the stuff we had taken out. So let's practice that again, just to make sure we get that before we use it today and build on. So first thing we do is group together first 2 terms plus group together the last 2 terms. And it has to be a plus in the middle, so if that third term is negative, that negative's got to stay in that second group. Then we factor out what's in common in each group. So what matches in the first group? X squared. If I divide an x squared out of there, what's left over? An x minus 2. Taking away x squared from the x cubed leaves 1x. Then from the second one, all went out, so there's just that negative 2 left. What's in common in the second group? 9. Negative, we're going to take the negative along with it, so we're going to divide out a negative 9. What's left when we divide by negative 9? X minus 2. 18 divided by negative 9 gives us the negative 2. What's left in those parentheses must match. If it doesn't, you've done something wrong. So then we are going to write that matching group, taking it now out to the front, times the leftover stuff. That's the factor by grouping process. And that's where all of our problems are going to end today. We won't be able to factor further, but we should always factor completely when possible. So linears don't go further. But what about x squared minus 9? X plus 3 and x minus 3. Okay. All right, we'll do one more factor by grouping example, and then we're going to combine these two ideas for our new stuff for today. So factor by grouping, I start by grouping together first two plus last two. What's in common in the first group? 3 and x squared. They both divide by 3. They both have at least an x squared. What's left over when I take that out?
3x minus 6.
X minus 2. Okay, so 3 divided by 3. There's no coefficient for the first one. X cubed, take out x squared. There's 1x left. We're dividing, so 6 divided by 3 gives us 2. X squared, I took out all the x squareds. In the second group, what's in common?
1.
Nothing, and we always need something, so we're going to write a 1. You must always take out something when we're factoring by grouping, so better than. Then we are going to write the matching group, taking it out front times the stuff that was left over. And that's our final answer. Questions on factor by grouping?
Oh, all right. When we have, like, when we factor by grouping, for this one, like, the second group of terms wasn't, factorable, we just had to take out a 1.
Mm-hmm.
For that, will it always be a case where we can't, simplify that group anymore, like in the one before?
Yep. Yep.
Okay.